Good morning, students. We'll again continue with our unit number 2, and the next topic is knowledge and uncertainty. Knowledge and uncertainty. So, knowledge about here, knowledge is regarded in context with decision making. So, knowledge is considered as the decision context, and it is the main success factor for optimal decision making, that is for minimum decision making. So in real world decision making, lack of knowledge, or in other words, lack of uncertainty of certain characteristics or surroundings in a normal situation, and it does necessary to be able to represent and deal with the uncertainty in a consistent manner. So hence it is very much important to represent and to deal with the uncertainty, and that too in a continuous manner. So the Bayesian statistics provides a basis for the consistent representation of uncertainties independent of their source, and readily facilitate for the joint consideration of purely subjectively assessed uncertainties, analytically assessed uncertainties, and evidences obtained through observations. So Bayesian statistics, this method is used to provide basis for continuous representation of uncertainties. And these uncertainties will be independent of their source and are readily available to facilitate for the joint consideration. Joint consideration of subjectively assessed uncertainty and analytically assessed uncertainties with the evidence as that are observed or obtained through the observations. So in the context of social decision making with time horizons reaching well beyond individual projects or the duration of the individual decision makers, the uncertainty related to system assumptions are of tremendous importance. So when it comes in from the societal point of view, decision making becomes very important because of the basis of time horizon, and this time horizons reach beyond the individual projects or the duration of the individual decision makers involved in those individual projects. So the uncertainty related to this type of system assumptions are regarded as very much important. So rather, different assumptions can be postulated in regard to future climatic changes, economical developments, long-term effects of pollution, etc. So it is obvious that if the wrong assumptions are made, then also the wrong decisions will be reached. So different assumptions based on these system assumptions, it is postulated that postulated in relation or keeping in mind the future climatic changes and also the economics, development, long-term effects of pollution, etc. So obviously, if the assumptions are taken as wrong or are made wrong, then the decisions will also be reached at a wrong level. So in the process of risk-based management decision making, where due to lack of knowledge, different system representations could be valid, it is essential to take this into account. So robust decisions, that is instant decisions, may be identified which, subjected to the possible existence of several different systems, will yield the maximum utility or benefit in accordance with the preferences represented by the decision maker. So these robust decisions, they are identified with the help of the subject context. This subject context is related to the possible existence of several different systems in a project. This system may yield the maximum utility or availability or benefit. You can yield maximum utility or benefit, and this is done in accordance with the preferences that has been cited by the decision maker of such a system. So uncertainty in regard to the performance of a given system or what concerns the existence of one or another system, it is a major influencing factor for the decision making, and it is necessary to take these uncertainties consistently into account in the process of decision making. So these uncertainties, as we have discussed, it should be continuously assessed, keeping in mind the during the entire process of decision making. So as discussed already in unit number 1, so there also exists a large number of proportions for the characterization of different types of uncertainties. To identify different type of uncertainties, different proportions or characteristics do exist that we have discussed in our unit 1. So it has become standard to differentiate between uncertainties due to inherent natural variability, model uncertainties, and statistical uncertainties. Whereas the first mentioned type of uncertainty is often denoted as aleatory, which is type 1 as discussed earlier. The two latter refer to as epistemic uncertainties as discussed in unit number 1. So however, the differentiation is introduced for the purpose of settling focus on how uncertainty may be reduced rather than calling for a differentiated treatment in the decision analysis. In reality or in real life, the differentiation into aleatory uncertainty type 1 and type 2, that is epistemic uncertainties, it is subjected to a model which is defined based on a considered system, a system that has been considered by the decision maker. Okay, so the relative contribution of the two components of uncertainty depends on the spatial and temporal scale applied in the model. So the model which will be considered by the decision makers, in their two components are considered, and these two components are dependent on the spatial and temporal scale. So for the decision analysis, the differentiation is irrelevant. Hence, a formal decision analysis necessitates that all uncertainties are considered and treated in the same manner. Next topic is system representation. So the risk assessment of a given system is facilitated by considering the generic representation, which is illustrated here in figure number 2, which the first event is exposure of events, second is constituent failure events and direct consequences, and the third is follow-up consequences. In short, it is the generic system representation in risk management. The first one indicates the events that has been exposed or that has been considered. The second one is the failure of events, continuous failure of events, and as a result of those failures, the direct results of the same, and then the follow-up consequences, that is the follow-up results of the same. So the exposure to the system is represented as different exposure events acting on the constituents of the system. So the constituents, that is the components of the system, can be considered as the system's first defense in regard to the exposures. In figure 3, an illustration is given on how results or consequences may be considered to evolve in the considered component or considered system. The damages of the system caused by failures of the components are considered to be associated with direct consequences or direct results as discussed. So, direct results or direct consequences, they comprise of different attributes in a system or different terms of a system. These terms may be of monetary losses, loss of lives, damages to the qualities of the environment, or change characteristics of the components. Based on the combination of events of constituent failures, that is component failures, and the corresponding consequences, follow-up consequences may occur. So if the combination of event failure often leads to follow-up results, consequences, or follow-up outcomes. So follow-up consequences or follow-up results, it could be caused by, for example, sum of monetary losses associated with the constituent failures and the physical changes of the system as a whole caused by the combined effect of constituent failures, that is component failures. However, as indicated in figure 3, an important follow-up consequence or follow-up result is in connection with the events that has been taking place and that is being like gaining the interest of the media, can be associated with very severe or very intense social economical losses. So these losses, it may be due to different political pressures. These political pressures in turn reacts to the disasters or severe or intense accidents in contradiction to optimal decisions or in opposition to optimal decisions or before a decision basis can be established at all. So the follow-up consequences or follow-up results in system risk assessment, it plays a major role. And the modeling of this should be given a great emphasis. So modeling of risk assessment system should be given a more importance. Exposure, that is the event. Then events impose consequences. The events that has been imposed as results leads to system change. Systems change leads to vulnerability, which leads to again direct consequences, and robustness leads to indirect consequences. Together, direct and indirect consequences leads to total consequences as a lot. Then this system changes is in turn returns to a perception of system changes, again where robustness takes place in social imposed or societal imposed conditions. This leads to indirect consequences. So as a whole, these two systems, that is system change and perception of system changes, leads to total consequences. So illustration of the evolution of consequences into direct as well as indirect consequences. So here from the figure, it should be noted that any component in a system can be modeled as a system itself. So a system could be a road network with components being bridges, or the bridges in turn could also be systems with components being structural members, and depending on the level of detail in the risk assessment, that is the system definition, the exposure, components and consequences or results would be different. So the vulnerabilities associated to risk associated with direct results, and the robustness is related to the degree of the total risk being increased beyond the direct results. So these three system characteristics, which will be defined in the following, are only meaningful subject to the definition of a system as outlined in the foregoing. System 1, highway network, 2 is a bridge and 3 is a wire. In system 1, there will be, in the highway network, there will be robustness or vulnerability, which leads to indirect consequences, and finally leads to network failure or road closure, or and so on. Next, bridge. In the bridge, indirect consequence means bridge failure, and direct consequences means failure of the support links in a bridge. System 3 is a wire. Here, indirect consequences is the failure of the cable, and direct is the failure of wire. So as you can see, the exposure of failure is basically traffic for system 1, traffic, axial load and HGV traffic. For system 2 is wind load, axial load and vehicle impact. For system 3 is wind, rain, induced vibrations, corrosion and fatigue. This is a generic system characterization at different scales in terms of exposure, vulnerability, and robustness. Next, exposure and hazards. So exposure of a system, it is defined as all possible endogenous, that is internal, and exogenous, that is external effects or factors with potential results or consequences for the considered or the system that is considered. So probabilistic characterization of the exposure to a system requires a joint probabilistic model for all relevant effects relative to time and space. Next is vulnerability. Vulnerability of system is related to direct results or direct consequences which is being caused by the damages of the components in a system for a given event. So the damage of the components of a system, it represents the damaged state of the system of view. So in risk terms, the vulnerability of a system is defined to the risk associated with all possible direct consequences or results integrated or sum up together over all possible exposure events. Robustness. The robustness of a system is related to the ability of a considered system to sustain a given damaged state subject to the prevailing exposure conditions, and thereby limiting the results of exposure events to the direct consequences. So it is of importance to note that the indirect consequences in a system not only depends on the damaged state but also depends on the exposure of the damaged state. So in a system when robustness is assessed or analyzed, it is important or necessary to analyze the probability or the chances of the indirect results as an expected value over all possible damage states and exposure events. A conditional robustness may be defined through the robustness conditional on a given exposure or on a given damage state or site. In a reliability assessment, a structure is designed having in knowledge or having in mind about the structure that is as built, and it is associated with uncertainty regarding geometry, material properties, loading and environmental conditions. So this uncertainty is in part due to inherent, that is internal variation, example like material properties, loading characteristics, and also a substantial part of the uncertainty arises from the lack of information. Uncertainty arises from the lack of information. In this way, the uncertainty related 2. Material properties in the design phase. It contains a significant contribution from the fact that materials manufacturer may not be known and because the material batch characteristics may not be known. Hence, the probabilistic models, the Bayesian probabilistic mainly, it is used in the design and assessment of a structure, which reflects the imperfect knowledge about the structure, and this knowledge may be updated as soon as the structure has been realized or released. So given that the requirements regarding the present and future use of a structure, it is specified that a reassessment process is a decision-making process. Then the purpose is to identify the measures which will lead to the most economical fulfillment of these requirements. So such measures or these decisions, it is mainly to inspect and collect information regarding the geometry of the structure, the material properties, the degree of deterioration of the structure, the static and the dynamic behavior of the structure, and the loading of the structure. So measures may also be taken or precautions may also be taken to repair or strengthen the structure or even to change the intended use of the structure. So whatever measure is taken, it must be evaluated and compared to alternative measures in terms of its consequence on safety, that is results on the safety and the monetary value throughout the required service life. So the following lecture summarizes the basic philosophy of the assessment of existing structures. So the purpose is to suggest a direction of thinking in assuring an appropriate performance of existing structures over their residual service life. More elaborated accounts on the same issue are available in JCSS Journal of 2001, where most of the required theoretical concepts are explained in detail. So the present text also introduces new perspectives to assessment of existing structures which have emerged over the last few years. Next, general philosophy of reassessment. So structures are planned, designed, constructed, and operated, and this is obviously subjected to a number of requirements, specifications, and assumptions. So requirements are purpose, that is the use of the structures, safety of the structure, reliability and fulfillment of the purpose of the structure, service life of the structure, and durability subject to normal maintenance of the structure. So these requirements, of which the latter three are understood, that is reliability, service, and durability is understood as requirements to the structural performance, directly or indirectly provide all the required information to design a structure. So generally, the design follows the relevant codes. As we know, relevant codes for the design and execution of any structure. These building codes or relevant codes include specifications in relation to the performance of the materials, testing, and quality control. So if a structure is designed and constructed according to a given requirement, it can be assumed that the structure is efficient and thus fulfills the given requirement. So however, this statement is valid only with certain limitations. So the major limitation is validity of all the assumptions on the basis of which the design was made. This includes assumption to the extent of degradation and damages of the structure does not exceed an intensity and extent. So these design assumptions in regard to local carrying capacity are no longer fulfilled. So as a result of this, three main issues are considered while assessing an existing structure. Effect of possibly changed requirements to the structure, then structural performance and validation of the design assumptions and assessing the effect of possible deviations from this. Also the third one, assessing the condition and residual capacity and service life of the structure. So now you can give your attendance in the chat box. I'll send the assignment in the group tomorrow. Thank you.